Let's do section 10.3, page 505, exercise 27, which reads, find A, the linearization, and B, the quadratic approximation of f at x equals 0. And for exercise 27, our function is f of x is equal to the natural log of the cosine of x. So the problem continues, but we'll get to that on the next screen. So part A asks us to find the linearization. So the first thing that we need to do is remind ourselves what the formula is for linearization from chapter 5. And that is L of x is equal to f of a plus f prime of a times x minus a. And in this case, a is equal to 0. And this is really a first order Taylor polynomial. So we know how to find this, and we can do it. We just have to find a bunch of derivatives. So we're going to start by finding f of 0, and that's going to be the natural log of the cosine of 0. And the cosine of 0 is 1, so this is going to give us the natural log of 1, which is going to be equal to 0. So now we have to find the first derivative. And remember that when we take the derivative of a natural log, we start by writing 1 over whatever is inside. And then we take the derivative of what's inside using the chain rule, and the derivative of cosine x is going to be negative sine x. And so this is going to give us negative tangent x. And so f prime of 0 is going to give us the negative tangent of 0, which is going to give us 0. So that means that the linearization L of x is going to give us 0 plus 0, or it's just going to be equal to 0. Now, part B asks us to find the quadratic approximation of f. And the quadratic approximation is the second order Taylor polynomial, which I've written down here. And so we really just need to take another couple of derivatives, because this part right here is the linearization evaluated at 0, and we already know that that's going to be equal to 0. So let's figure out what the second order derivative is going to be. And the derivative of negative tangent x is going to be negative secant squared x. And when we evaluate that at 0, we are going to get negative 1. So P2 of x is going to be equal to negative x squared over 2. So we've answered parts A and B. And part C says, graph the function and its linear and quadratic approximations together around x equals 0 and comment on how the graphs are related. Now, when I graphed this with my calculator, I used a window that went from -3 to +3 in the x direction, and then it went from -3 to 1 in the y direction. So I'm going to start by plotting the easy thing, which is going to be L of x, which is equal to 0. So I'm just going to follow my x-axis here as best I can. So this is going to be L of x. If I plot my quadratic approximation, that's going to be negative x squared over 2. And so let's just pick a different color here. And that's going to be a parabola. So this is going to be P2 of x. And then I finally plotted the natural log of the cosine of x, and I get something that looks a little more like that. So this is going to be the actual function, which is the natural log of the cosine of x. So this is going to be f of x. And I would say that close to x equals 0, both approximations do a pretty good job. When we get farther away from x equals 0, not so much, although the quadratic approximation does a better job than the linearization. And I think we can also say that L of x, the linearization, is tangent to both the quadratic approximation and f of x at x equals 0.